Hi guys, welcome back. I hope you're having a wonderful day. We are going to jump right into section 1.2. So in section 1.1, we talked about how to write rational numbers as fractions, okay, as in the form of m over n. Today we're going to talk about writing rational numbers as decimals, which I know some of you prefer and some of you don't, but we want to be able to do it both ways, okay? So just as a remembering, so 3/10 we write as 0.3 because the 3 is in the tenths place. 21 over 100 we write as 0.21 because the 1 is in the hundredths place. If we have 5 and 323 over 1,000, the 5 becomes the whole number before the decimal. And then we have 323 as our decimal place, and the 3 at the end is in the thousandths place, so that works out, okay? So just as a recall, we kind of remember that. We've discussed that a little bit earlier in this week. So all these denominators are multiples of 10, so they're very easy decimals to find because we can put them in a place value. If we can get a number to look like 100, that's even better because then we can just do the same thing. But sometimes denominators will not have multiples of 10, so we'll have to look at that as well. So we can use long division to find any fraction into a decimal or to change any fraction into a decimal. So if we're going to do that, so this one, some of you might say, well, I know I can make 4 look like 100 on the bottom. I can multiply the top and bottom by 25. So then I get 25 over 100, which would be the same as 0.25. Okay. Now, if we didn't know how to get 4 to be 100, another way we could do this, so this is an or, you don't have to do it both ways. You could say 4 goes into 1, and we're going to put a decimal and a couple extra zeros here. Okay, so I would say 4 can't go into 1, it's 0 times, and then as soon as I hit my decimal, I want to make sure I bring that up. And then I would say, can 4 go into 10? 4 can go into 10 twice, and we have 8 left over. And when I subtract that, that gives me 2, bring down my 0. And 4 goes into 25 times. So again, I get my 0.25 no matter which way I do this. Okay? So if it easily gets to 100, we can use that method. If it doesn't, we have to do long division. Okay? Let's look at a different one. So terminating decimals is a decimal that ends. So like 0.25 is a terminating decimal because the decimal stops. 0.2222222 going on forever is not terminating because it goes on forever and ever. Okay? And the remainder would be 0 when we do our long division for a terminating decimal. Okay? So if we want to change 3/8 into a decimal, we can't multiply anything by 8 to easily get to 100. And some people tell me, they're like, well, why don't I just divide it by 2? Then if you divide the top by 2, you're going to get a fraction over a fraction, and that's not fun to deal with right now, okay? So we're going to always put the bottom number on the outside, okay? And the 3 goes inside, okay? And I'm always going to tack a decimal and a couple zeros if that's not already there, okay? And again, I'm going to say 8 does not go into 3, so I'm going to put a 0 and pop up my decimal. 8 goes into 30, though, and that would be 6 times. I'm sorry, not 6 times, 3 times. 8 times 3 is 24. Okay. Then I'm going to subtract those to give me 6. Bring down a 0, just 60. So 8 is going to go into 60. How many times? So 8 times 8 is 64, so it's going to be 7, which would be 56. And I'm going to go ahead and subtract. 60 minus 56 would be 4. Bring down my 0. And 8 goes into 45 times. So when I subtract that 40, my remainder is 0. So I know it's a terminating decimal. Okay? So my final answer here is 0.3575. Okay? So terminating decimal means it ends. Okay? Let's go ahead and look at this one. So I'm seeing I have a whole number and a fraction. So as soon as I see a whole number, I know it's going to be 6 point something. I just need to figure out what that something is, and that's my fraction. So I want to change 2 25ths into a decimal. So I could do this 2 ways. I could do my long division, or 25 nicely goes into 100. So I can multiply the top and bottom by 4 because 25 times 4 gives me 100 and 2 times 4 gives me 8. Now this tells me 8 needs to go into the hundredths spot. So that means I have tenths, hundredths, so 8's going to go there. So I need to put a 0 there. So this is 6.08 or 6 8/100. Now we could do the long division, so this would be an OR, so it'd be 6 point something, we know. If we do 25 into 2, add some zeros. I know 25 doesn't go into 2, so that's a 0. Bring my decimal up. Oops, decimal. And then 25 also does not go into 20, so I have to put another 0. But I do know that 25 goes into 208 times. Okay? So that's where we're getting the 0.08 again. Okay? So again, if it equals 100 easily in the denominator, you could go either way. But if it does not equal 100 in the denominator, then you have to do long division. Okay? All right. And this is just what I spoke about with the 6 in front. Okay? So let's do another one. So 7/8. There's no way I can get 8 to look like 100 nicely. So I'm going to say 8 goes into 7. Okay, so 8 does not evenly go into 7, so I'm going to put my 0 and bring out my decimal. Does 8 go into 70? Well, 8 times 8 is 64, so I think that's good. So 70 minus 64 is 6. Bring down my 0. 8 goes into 67 times to give me 56, because 8 times 7 is 56, and then subtract to 4. Bring down my 0 here, and remember I can always add more zeros if I need them. Well, 8 goes into 45 times, so I have 8.75 as my answer. Okay. I'm going to go ahead and shrink this so that way I have my room back over here. Okay, again, 10 and 13/25. So go ahead and try this writing it as a decimal for me. And remember, this is going to be my front number, so this is going to be 10 point something. And 13/25 nicely goes to 100, so I'm going to multiply top and bottom by 4. So 13 times 4 would be, 13 times 4, I'm blanking, so I'm going to do my math off to the side, 12. 4 times 1 is 4, 52, oh goodness, I knew that one. 25 times 4 is 100, okay. So again, the 2 has to go in the hundredths place, so this would be 0.52. Okay. Again, we could do the long division if we wanted to get that same answer. Okay. All right, next page here. If you do not have these notes on the next page, just go ahead and continue writing for me on the back side. All right. So also we can have what's called repeating decimals. So repeating decimals have some sort of pattern to them, okay? So 1/3. Most of us might know what that is off the top of our heads, but we're going to practice the long division. So again, 3 into 1. Remember, the bottom number always goes on the outside. So 3 does not go into 1, so we bring our 0 and pop up our decimal. 3 does go into 10 3 times. Whoops. So that gives me 9. Subtract gives me 1. Bring down my 0. 3 goes into 10 3 times, which gives me 9. Subtract 1. Bring down my 0. And we can already start to see a pattern happening, right? This will never end. The 3 is going to keep repeating forever. Okay, so we don't need to go too far until we start to see that pattern. So we can write this as 0.0333. We could just keep writing forever with ... Or there's this special symbol. The repeating part can have a little bar over top of it. Okay, it has some fancy math name, but we'll just call it a bar. Okay, and that tells me that this part, this number right here, is what's repeating forever. Okay, so that bar. Now, if more than one number is repeating, then that bar should go over the number, all of the numbers that are repeating, not just one of them, okay? All right, let's try another one. So 12 into 13. And again, that is not easily able to get to 100. So 12 into 13. Add some zeros. So I know 12 goes into 13 one whole time. And 13 minus 12 is 1. Bring down my 0. And I know I'm going to pop up my decimal because I'm hitting that right here. I didn't switch to another color. Sorry, guys. This is 1 and a 0. So 12 does not go into 10, and since I already brought down a 0, I'm going to put a 0 here. And I'm going to bring down another 0. So 12 will go into 100, and 12 times 8 is 96. And if we subtract, we're going to get a 4, bring down our 0. And 12 will go into 43 times. Should be 36 with a 4. Bring down my 0. That was a bad 4, sorry. And then that'll go in 3 times for 36. And if I subtract again here, let me shrink this. If I subtract again, I notice I'm getting a 4 and then a 0. So I can start to see that pattern forming that I'm constantly going to get. Let me get a different color pointer here. That I'm constantly going to get this 4 every time I subtract, okay? So the 3 is what's repeating. So I can write my answer as 1.083, and we're going to have a bar just over the 3 because that's the only part that's repeating. Okay, so that's kind of it for long division for this one. If we need to compare rational numbers, we can transfer them to decimals if it's not obvious which one is bigger. But another thing we can do is just get a common denominator. So here my common denominator would be 20 because 4 times 5 is 20. So to get to 20, I'd have to multiply by 5 over here, which gives me a 15 in the numerator. And here I would have to multiply by 4, which gives me 16 as a numerator. And we know 16 is bigger than 15. Okay, so which one's bigger for this one, 1/3 or 2/5? So again, I'm going to get 15 as my common denominator. And I don't have to do the bottom because I already know it's going to be 15. So to get 15, I have to multiply by 5, which would give me a total of 5 on top. Here I have to multiply by 3, and 2 times 3 is 6. So 6 is bigger than 5. So 2/5 must be bigger than 1/3. I hope you are having a wonderful day, and I will see you later. Bye.